So question 8 is a projectile motion question, and it's a bit of a dodgy one at that. I actually wasn't sure about the answers for some of the later parts, but we'll go with it anyway. So we have two things, two different objects undergoing projectile motion. So we're going to have 4 different sets of Suvat values. So we have 2 different objects and 2 different directions, so that's 4 different sets of Suvat values. So first of all, to make things a little bit easier, we'll say the point at which they collide is, well, for argument's sake, we'll say maybe it's like here, okay? So the way we're going to do this is we'll label this as a distance which we'll call x, because why not? When p is going over to the right, it's going to go as far as d minus x. It's d without that x, so it's going to be d minus x. The initial velocity, we can see it's 38 and the angle is 41, so it's going to be 38 cos 41. The final velocity we're not going to worry about, because remember, in the horizontal, there's no acceleration, so a is 0, so we don't actually need to worry about v. And then the time taken, well, we know they collide at t equals 3, and p is projected at t equals 0, so it's going to spend 3 seconds traveling. Now for p in the y direction, it's going to be some height here, as you can see, and we'll just call that h. So we'll say the displacement is h. The initial velocity will be 38 sine 41. The final velocity, we're not going to worry about it, because usually we don't really need to. For acceleration, we have minus g, and the time taken is 3 seconds as well. Now, for q in the x direction, well, you can see it travels the distance x to the left until where it collides, so we're going to have minus x, because it's going to the left. The initial velocity will be minus u cos 64. Final velocity we don't really care about. The acceleration is 0. And now this is released at t time equals 1 second, and they collide at t equals 3 seconds, so it spends 2 seconds traveling. For the displacement in the y direction, well, it's still going to be that same height h, because when they collide, their displacement's going to be the same, so their y displacement, both of them will have a height h. The initial velocity will be u sine 64. The acceleration is minus g, and the time taken is 2 seconds again. So we're trying to show that u is 28 meters per second to the nearest whole number. So if we have a look at our equations, if we look at the x equations, we have d, we have x, and we have u. That's 3 unknowns, but only 2 equations, so that's not really going to work. If we look at the y ones, however, we have a h and we have a u. So we have 2 unknowns, 2 equations, we can work with that. So we'll start off with p in the y direction. So we'll write p, and we have SUAT, so we'll use the equation s equals ut plus a half at squared. So we'll have h equals, sorry, it's going to be 3 times 38 sine 41. So 3 times 38, so it's going to be 114 sine 41. So that's just ut, that's 3 times 38 sine 41, minus, because we have minus acceleration, g, which is the acceleration, then t is 3 squared over 2. Now we'll just simplify this, because we can just put all this into one value on our calculator. That's about 30.691 meters. That's what h is. So we now know what h is, and we can use that in the other y equation. So if we go for q in the y direction, so q, we're going to use the same equation. So we're going to have h equals ut, so that's going to be 2u sine 64. And then it's going to be minus g, then time t is 2 squared over 2. And we know h is 30.691, so we can replace the h with 30.691. We have 30.691 equals 2u sine 64 minus, now 2 squared is 4, 4 over 2 is 2, so minus 2g. Now we can just solve for u. So we'll have 30.691, take the 2g over to the other side, plus 2g, and then divide by what's attached to the u, 2 and sine 64, 2 sine 64. That'll be our value for u. When you put that into your calculator, you'll get 27.977, and it says to the nearest whole number, show that u is 28. Well, we got 27.977, so we can say that's 28 meters per second to the nearest whole number. Next, we're asked to calculate d, so we can go back up to our equations, and we can look at the x directions now, because they're the ones that have d in them. So I'm just going to copy them down there. So for these ones, because there's no acceleration, the equation will actually just be s equals ut, because then plus a half at squared, a is 0, so it's just s equals ut. So we'll do that for the p. So we'll have d minus x equals 114 cos 41. And then for q, we'll have minus x equals minus 2u cos 64. Remember, we found u to be 28 meters per second in the previous part. So we can say x equals 2 times 28 is 56 cos 64. So we actually already have a value for x, and we can just plug that into the equation for p, and we'll get a value for d. So you can say that d minus 56 cos 64 equals 114 cos 41. That means that d equals, bring that 56 cos 64 to the other side as a plus, and we get that d is about 110.586 meters. So now we're asked in terms of I and j, calculate Vp, the velocity of p, and Vq, the velocity of q, when they collide when t equals 3. So first of all, for the x directions, remember that there's no acceleration, so the initial velocity will be the final velocity. So we actually already know that. So the initial velocity for p is 38 cos 41. We'll just get a value for that. So we can say that for px, it's about 28.68. We'll do 2 decimal places. I, and for q, now remember q's one will be negative because it's going to the left. So we'll get a value for, remember, u is 28 cos 64. So we'll get minus 12.27 i's for q. Now for the j direction, we have a little bit more work. So let's look at py. So we're going to solve for v. So we have vu and a and t. So this is for p. So we have v equals u plus at. Sorry, this is py. So we're going to have v equals u is just 38 sine 41 minus 3g. Put that into the calculator and it'll get about minus 4.47. So we can add that in here. So it's going to be minus 4.47 j's. Now we'll do qy. So same thing. We don't know what v is. So v equals, and we're going to have u, which is, remember, u is 28. So we're going to have 28 sine 64 minus 2g. And that's about 5.57. And if you think about it, that does make sense because q has been in the air for less time. So that means that gravity has had less time to pull it down. So it actually has a higher, it's going upwards, it has a positive j velocity. So now I probably should have written this properly. So we're going to have Vp is going to be that, and Vq is going to be that. And that's the answer. Next, we're asked to calculate the dot product of Vp and Vq. So this is on page 17 of the Formulae and Tables book. Scalar product's just another name for it. So we have two things. It's the x velocities plus the y velocities, or the magnitude of each of the total velocities times the cos of the angle between them. So we don't know the angle, so we'll just use the first definition. So it's going to be the two x velocities plus the two y velocities multiplied together. So we can say that Vp dot Vq equals, so the two x velocities, so we're going to have 28.68 multiplied by minus 12.27 plus the two j velocities multiplied together, minus 4.47 times 5.57. And if you put that into your calculator, you got minus 376.8 approximately. So part 5 is the part I wasn't too sure about. So if you draw out Vp and Vq, as you can see, there's no acute angle. When you're asked for an angle between two vectors, it usually means when their tails are touching each other. And here their tails are touching each other. And as you can see, there's no acute angle. So either, there's two possibilities. Either this was a typo and they're asking for the smaller angle, which would be this one. Or they're asking you not to do it from the tails, so you'd slide one onto the other. And as you can see now, there's a few acute angles. So I'll show you what I would have done. So first of all, we know that the dot product is the two magnitudes times the cos of the angle. So we know the dot product is minus 376.8. So we can say minus 376.8 equals the magnitude of the first one. So remember, to get the magnitude, it's going to be, I'm just going to do this all at once, the square root of the x1 plus the y1. So for Vp, we'll have 28.68 squared plus 4.47 squared. Because if you think about it, this is for Vp. So you're looking at how far it goes out. You're looking at how far it goes down. And it's like Pythagoras' theorem. You're adding this one, and you're adding this one, and you're taking the squaring each one and taking the square root, and that'll give you the hypotenuse, which is the magnitude of the vector. Now we just do the same for Vq. So we're going to have the square root of 12.27 squared plus 5.57 squared. And then remember, it's the two magnitudes times the cos of the angle, so we'll times cos theta. Now, if we divide both sides by these two big square roots, we'll get the cos theta equals minus 376.8 over this big thing. And if you put that into your calculator, you'll get the cos theta is equal to minus 0.963 approximately. Then to find theta, you'll just do the cos inverse on both sides. And you get the theta is about 164.37 degrees. And this is going to be the smaller of the two angles between the vectors. So that's actually this angle, 164. So technically this right here is the angle between the vectors. But because they ask for an acute angle, I think what they want you to do is they want you to slide the vectors on top of each other. And now we have two acute angles. How do we find it? Well, remember this 164, that's just this part. And as you can see, we can get this angle by doing 180 minus 164, because that'll give this angle here, because it's a straight line, which is 180. And then we have that red bit, which is the 164 that we calculated, and then we can find that green bit. So if we do 180 minus 164.37, that'll give us 15.63 degrees as our final answer. So if they're looking for an acute angle, that's it, but technically that's not the angle between vectors, because the angle between two vectors is defined to be when their tails are touching, like this. So, I don't know, maybe they made a typo, maybe they just were too ambiguous and they didn't say that they wanted the vectors to be where they wanted the vectors to be with the tails touching or whatever, but it's either going to be 164 or 15.63. I wouldn't be surprised if they accepted both since they were so not specific about it, but yeah, they're the two angles, and that's how you do it.